Welcome to the Lightning Network Tech Talk. So I think the Lightning Network is one of the most exciting things about Bitcoin today. And it's the one way I know that we can help Bitcoin scale without losing decentralization and security. So I think it's going to be huge. I'll let these guys introduce themselves. Welcome.
Hi, I'm Thaddeus Dryja. I'm working on this with.
Hi, I'm Joseph Poon. How are you?
And we've been working on Bitcoin stuff for a while and started working on this a while ago, but full time like September or so. After we gave the initial talk like last February. So I will start maybe half of it, and then Joseph will talk about half, and then we'll do questions.
Yeah, and like the presentation is going to be like introductory. There'll be a lot of like rehashing if you've already like seen the other videos, but I think like the more interesting part will probably be the Q&A session.
Yeah, so because there's probably a variety of people who know all this stuff already, people who don't. So if there's questions, please ask during and interrupt, no problem. And I'll go sort of quick because there's probably a lot of people who know some of this already. Okay, so how can you make Bitcoin work for millions of people? I'm sure, as you're all aware, people have been arguing about scalability quite a bit on the internet, and that whole thing. Yeah, and then there's like talks about it. So, how can we actually get this to work for gazillions of people? The fundamental problem is that, when you're running a Bitcoin node, every node has every message. Every block goes to every, computer. So it's sort of like if the whole internet's on one Ethernet hub, which is like, they don't even use hubs anymore, they have switches, or sort of like one Wi-Fi access point for the entire planet. And that's hard to scale. So currently there's a 1 megabyte limit every 10 minutes, which I'm sure everyone knows about because people keep arguing. So global consensus is needed in Bitcoin. You've got to have everyone on the same page about every single transaction, but it's very inefficient. So there's people who want to directly increase the messaging rate, which can help, but it's probably not enough. It's sort of like having a faster access point. So if everyone in the entire world is using one AP, and you say, okay, let's go from 802.11n to 802.11ac, yeah, you're going to go 3 or 4 times faster maybe, but that's not the order of magnitudes we need. So you could double it to 2 megabytes, you get a linear increase. And as you keep doing that, you're going to see a drop-off in people actually running it because it's harder to run. So segmenting the network is generally the way people do this, is saying instead of having one access point for the whole world, we'll have one access point in each room, we'll have hubs, we'll have switches, we'll have a hierarchical system. So that's generally how to do it in networks. But how do you maintain the same global state and security as Bitcoin? You can't really just say, oh, every country will have their own blockchain. Or the whole idea of Bitcoin is you want it to be like one thing for the whole world. So the way Lightning works is it extends previous research on payment channels. Okay, so what's a payment channel? A payment channel is basically a whole bunch of Bitcoin transactions, most of which do not get broadcast to the network and included in the blockchain. So, transactions can be delayed and aggregated, and you only need to actually broadcast the first and last transaction. So you broadcast a funding transaction, which creates the channel, and a closing transaction, which closes out the channel. Slight detail. When people are fighting, you actually have 3, because then there's 2 closing transactions, kind of, which I'll get into in a second. Okay, so one transaction to start, which is basically, have Alice and Bob. They both send 1 Bitcoin into a multi-sig address, which is the channel itself. It's also possible that a channel can be funded by only one party. So Alice is saying, hey, Bob, I want to open a channel with you. And maybe Bob's not too keen on that, but he says, well, I'll have a channel with you, but I'm not putting any money into it. So Alice just funds it herself. That's also possible. And to close the channel, that multi-sig address then spends back to Alice and Bob. And in between there, you can create a whole bunch of different closing transactions, which give different amounts to the 2 people. So maybe Alice funds it initially with 5 coins and sends 1 to Bob and 4 back to herself. Bob has that transaction on his hard disk, but doesn't broadcast it and sort of waits. And then Alice can give him some more. He can give Alice back some, and they can keep going back and forth between each other. And either of them can close at any time, but they don't because it's really convenient to have this channel. So yeah, it just uses multisig, and I'll skip this because you have a more detailed. Okay, there's more detail about this later. But basically, you want it so that at any time, one of the parties can go offline or turn evil or get hacked or whatever, and it still works. So there's these non-cooperative outputs. In general, when everyone's working together, it works great. You'd fund it, and then you have a regular multi-sig transaction to close. But the transactions you have on your hard drive, which you don't use, are a little bit more complex in that they say, okay, this is money going to Alice if she knows a secret, or Bob if he waits a week, is the sort of script with opcodes that you use. And then you revoke that transaction by revealing that secret. So Alice says, okay, this is my money. I just have to wait a week. And then I can sort of rescind my claim to that money by revealing to Bob that secret. Sorry, I got it backwards. I can reveal to Alice that secret. So you update the channel state. It's like sort of two back and forth where you say, okay, I'll sign off on a new state. It used to be you have 1 coin and I have 4. Now you have 2 and I have 3. I'll sign off on that, give you the signature, and then we'll exchange the secrets to destroy the old state. And so once we have each other's secrets, we're never going to broadcast that because the other party can just take all our money. Okay. And so there's a little bit about how that works in terms of opcodes at the end. The problem with a single channel is it's useful for recurrent services, metered things, paper hour, etc. But most payments are one-time things. You don't buy a shoe and then buy the next shoe. You just buy a pair of shoes and you're done. Most of the time when you go to a restaurant, you're not going there very frequently. So how do you extend these channels to more use cases? If you had to open a channel to every person you're transacting with, you don't gain that much. You can have a MultiHop network. So if Alice and Bob have a channel and Bob and Carol have a channel, can Alice pay Carol without making a direct, A to C channel? This would allow a sort of network where you could have a large high throughput network, all these channels sort of make links like the internet. It'd be really cool. And if you trust B, then it works great. And even if you only trust them a tiny bit, it sort of works, right? You say, okay, Alice and Bob have an X channel, Bob and Carol have a channel, and Alice says, okay, Bob, I will give you 1/100th of a Bitcoin. Please forward this to Carol. Bob forwards it to Carol, and then Alice asks Carol, hey, Carol, did you get it? And Carol says, yeah, I got it. And Alice says, okay, cool. Bob seems to be working well. I will give him 0.2. You get it? Yeah, I got 0.2. And they can incrementally do this. So that way, the worst case that can happen is Bob grabs the 0.01. That's actually pretty bad, though, because Bob can just keep it. Also, Carol can claim she didn't get the coins even if she did, if she's in cahoots with Bob. Like, there's all sorts of issues with this. It might work, but once you have a bunch of hops, you won't even be able to tell who ripped you off. So it doesn't really scale that well. So you want a whole bunch of parties to be able to forward payments without actually trusting the intermediaries at all. Also, once you don't have trust in the intermediaries, you don't care who's in the middle. They can be totally anonymous, just represented by Bitcoin addresses. Similar to how you don't really care who mines your transaction. It just doesn't matter if, Bitfury does it or, some Chinese miners, whatever, it's the same. So similarly, you want these guys in the middle to be anonymous, like you don't care who they are. So the way you would do it, the receiver, so in this case, Alice is paying Dave. And these blue lines are channels, but then there's also going to be like a TCP connection between Alice and Dave. They have to be able to talk to each other. So Alice talks to Dave and says, hey, Dave, I'm going to send you a coin. Dave creates a random number, hashes it, sends Alice the hash of that number, and keeps our secret for himself. And then Alice says, okay, Bob, I will pay you a coin if you know R. I'll say, if you know the preimage of H, which is R, I'll pay you. Bob does not know R. Bob says, okay, Carol, I will pay you if you know R. Carol says, Dave, I will pay you if you know R. Dave knows R. So Dave can consider that payment legit. But the interesting thing is, if Dave tries to broadcast to the blockchain, he must reveal R in order to accept the payment, in which case all of these conditional on R payments can all happen because everyone will know what R is. He doesn't have to actually broadcast to the blockchain, though. He can just say, hey, Carol, here's R. And then Carol tells Bob. Bob tells Alice. Everyone knows what R is. And then actually after this sort of everyone knows R, all the payments have happened atomically, you can clear out And Alice can say, okay, well, I'll just pay Bob regardless of R to update the state, so we can clear out this R thing. That helps in that the end state doesn't. You don't have to keep track of R long term. Well, sort of. So as long as there's a path, payments can be routed just like in the internet, which is cool. Okay, Joseph will explain some sort of more technical details.
Yeah. So what's going on is that, let's say you're Alice, right? You have like 5 connections to people. There's Bob. There's like some other person. There's like Nancy or whatever it is. Alice has like 5 connections to people. She can route to really anyone on this network, through this type of graph topology, similar to the internet, where you route your packets. And this is all done off chain. The examples earlier were they at any time all of these payments functionally are all Bitcoin transactions, right? This is not some like separate layer. There's no custodian. There's no 1-800 number to call. This is designed in such a way where like at any point in time, the Bitcoin transactions exchange can be broadcast on the blockchain. Now, what that means is all these rules and scripts are using Bitcoin scripts, right? So what happens is, as a result, is you can make these types of payments where you could broadcast on chain, you could broadcast the redemption and prove you can redeem by broadcasting R, but you elect not to, simply because it's more efficient to do it off chain. But it's through this proof and knowledge that you can that really matters. But these individual links, how do they work, right? And that's sort of like, that's the most important part, to understand how it works. I assume most people in this room understand, like, ideally how multisig works. I want to drop my drink. Yeah, so with multisig, like you have an output that requires both parties to agree. And so let's say Alice and Bob wanted to create this link, right? And let's say this link didn't exist yet, right? What they do is, a naive view of this would be, and this is not a correct example, I'll go into that later, would be, Alice has 0.5 Bitcoin, Bob has 0.5. They both send an output to 1 Bitcoin, but before this is broadcast on the blockchain, they make a refund, right? And the dotted line means, it's not broadcasted on the blockchain yet. So what happens is there's an actual ledger output as part of the UTXO set where they say, okay, there is, a P2SH3 address on the blockchain. It's not spent. It's fully unspent, right? But either party can broadcast this. Both parties have a copy with these outputs, right? So what happens is they have they just leave an unconfirmed transaction on their hard drive and don't broadcast it. That's functionally what's going on. So what happens is they fund that, it goes on chain, and it's sort of, like they have their money, They have 0.5 Bitcoin because at any time they just broadcast that and hey, it's their money again, right? Now you can update that state, right? What if they wanted to update from 0.5 to 0.3.7, right? So they could create another, unconfirmed transaction. They say, hey, now we have a separate transaction. They both exchange signatures. It's a 2 of 2 multisig, and they both say, okay, I sign, you sign. They exchange it, and now, hey, the channel state is now 0.3.7. Oh wait, there's a problem, right? There's still that old transaction, dotted line. It's unconfirmed. It's not broadcasted on the Bitcoin P2P network. It's on each other's hard drives. But hey, like if I'm Bob and I say, hey, I mean, if I'm Alice and I paid Bob, right? And, like Bob thinks it's 0.7, it's like, okay, this is what it is. Then, I keep looking at that. Then Alice can still broadcast this transaction. That's not good, right? This is fundamentally the double spend problem. Like the point of Bitcoin is to solve this problem, right? How do you solve this double spend problem off chain? And fundamentally, like the way you solve it is through economic incentives. So what we really need to do instead is to make it so that the old state isn't broadcast, right? You can't prevent someone from making that broadcast, but you need to make it so that they won't. And you make it so they won't, so that like they will only broadcast the current one, and all prior states will be invalidated. So imagine if there were like 100 or 1,000 or millions of these, only the current one will be broadcast on the blockchain. So how do you invalidate, right? How do you order transactions off blockchain, right? Can you do that? So you do it by making it potentially enforceable at all times. So you say there are off-chain transactions that can be broadcast, but you create some enforceability mechanism as a result. So how does that actually work? So there's going to be a lot of boxes. Pay attention. These are Bob's transactions. Bob has a set of transactions that he can broadcast. They are different than Alice's. Alice has a separate set. Alice has a set. Bob has a set. You're only seeing Bob's set right now, okay? And they both exchange signatures. And when they exchange signatures, they are exchanging the other party's set. Okay. What happens is that you make it so that it's not simply everyone gets their money back. What happens is you make it so that either of these can be broadcasted at any time. Bob can elect to broadcast that one, and Bob can elect to broadcast the other one. This is the correct one, right? So what happens when Bob broadcasts this one, right? Alice immediately gets her money back, and Alice immediately gets her money back, whichever one is broadcast. But since Bob is broadcasting this transaction, this is Bob's, this is time blocked to some agreed upon time, let's say 3 days, right? And as part of making this new one, Bob gives Alice this transaction. So this is actually Alice's, right? Yeah. And they exchange the signature. They give the signature. But yeah, it's technicality. Yeah. So what actually happens is that, let's go through what happens. Okay, with Alice, it's different, right? Under this system, right, Bob gets his money back with a delay because Bob is responsible for broadcasting this. Alice could get it back immediately. Similarly, if Bob broadcasts the most recent one, Bob must wait 3 days. If Alice is responsible for broadcasting, Alice has to wait 3 days. The underlying idea of this is that if you are broadcasting a transaction on-chain, you are attesting a state inside this channel, right? When you attest a state inside a channel, you need to be able to prove that that is the correct state. The other party doesn't have to prove anything, right? Just if they have 0.5, you're like, okay, I assume they have 0.5. It's the money that you get back that you need to prove. So the money that you get back is time locked. And you're creating this statute of limitations where within these 3 days, the other party can claim the funds if you're a liar. Like if you're not attesting the correct state, the other party immediately sweeps the funds, right? They see this transaction on the blockchain, they're like, oh, no, that's not right. They immediately sweep. So let's look over what happens if they're honest and dishonest. So right now, the channel's still open, right? This is the UTXO state. None of these transactions are broadcast. And then let's say Alice wants to close it out. She's just like, I'm done talking to Bob. I just want to close it out. I just want to say, okay, we're done with this relationship. I just want my money. Sorry, am I redundant? No, okay. Yeah. Well, they don't have a good relationship. Let's say, they're doing good before, but, someone's being unreasonable. In this case, this is a mutually agreed upon separation where, no one's being a jerk. Well, it's not mutually agreed upon. One person wants it, the other person doesn't, but they're reasonable about it. So Alice is like, okay, I'm going to be reasonable. Oh, this should be 0.3. Okay, well, this should be 0.3. Let's pretend this is 0.3. So Alice broadcasts this one. She gets her 0.3 back. Bob immediately gets 0.7, right? And that's fine. Bob gets his money back immediately. Alice waits 3 days. She's good. There's no problem. But what if Alice is a jerk? If Alice is a jerk, she broadcasts this one. Bob immediately gets 0.5 back, right? So Bob's like, okay. But Bob's like, whoa, this is no good. This is no good. Alice can get her money back in 3 days, but what happens is that Alice, as part of making the current transaction, she invalidates the old one by exchanging the secret. So what happens is Bob can redeem this output immediately. So all prior transactions have the other party able to do it, able to redeem it, right? So if Alice broadcasts incorrectly, Bob can immediately sweep the funds. Similarly, if Bob broadcasts incorrectly, Alice can sweep the funds. So that's a very different construction. So what ends up happening is the blockchain really looks like a dispute mediation system. By having these systems of timeouts and giving a chance for the other party to dispute the test of state, it becomes this like smart contract structure involving multiple transactions. And contracts work in real life this way. When you write a contract, like a legal contract, people write a lot of those. You sign a EULA. Well, EULAs aren't that enforceable, but let's say you write like, an employee contract or a rental agreement or whatever it is. You're not going to the courthouse every single time, like you're not going to the judge and be like, hey, this is what's going on. It's really only if there's a dispute or some type of large, some type of disagreement or some type of structure where you really go to court. And this is a similar type of system where, if both parties agree, they can agree to the current state and they can come to some form of consensus. But it's trust but verify, right? You need to be able to have an enforcement mechanism in order for it to be effective, and the blockchain becomes this enforcement mechanism. What's interesting is that the enforcement mechanism is programmatic, right? The transaction's either valid or not valid. It's a 1 or a 0. There's no like convincing the judge. So the neat thing is, as a result, all transactions, they're all valid and they're real Bitcoin transactions. But broadcasting the old one, you lose all your monies. And you can tell a third party to watch the chain for you. So you could say like, you tell this third party, you're like, hey, I don't know if this Bob guy's a nice guy. Just watch out for him, and you just give those penalty transactions to this third party. You're not really trusting them with anything, and they could hypothetically collect a small fee if they wanted to, but you can come to some agreement on that. And as a result, you can have multiple third parties. You can have like 100 or 1,000 or whatever, each collecting their own fee, and they could like race to get the penalty transaction in on your behalf. Pretty fun. So I'm talking about Coinbase. What does this really mean for Coinbase? I think it's fairly obvious what the interesting applications are, but in terms of technical design, what are some interesting implications, right? Under this design, these are hot wallets, right? When you're flowing money between these different participants, it's all done programmatically in software. These keys are live, right? You can construct lightning channels where they are cold, where you keep your keys, in cold storage, and every time you want to update the state, you have to do this transfer. But in order to do high volume instant payments, there are live keys. And that's something to keep in consideration, right? You want to keep as little as possible hot and as much as possible cold. As a result, you may not want to directly connect to customers. There could be this bifurcated model where, for small channels, you may have direct relationships with the customers, but for larger channels, you probably don't want to, because the money is locked up and those keys are potentially hot. So you may want some type of restriction on the smaller channels, but for the larger channels, don't. I don't know. Like directly connecting to people could just lock up a bunch of funds hot, right? And a way to go about this, because this is a routed network, right? What you can do is, just route through, 3 or 4 intermediaries to eventually get to you. And functionally for the users, it's really the same. Now, there's nothing stopping you from, like connecting to everyone and leaving a bunch of money hot, but, there's some complexities around that. Whereas if you just have, 100 participants in this network, let's just say randomly, then it's sort of like, well, if those funds are hot, that's sort of like, it's a more understandable hot wallet cold storage management that is, something that I'm sure you're more familiar with. The protocol is going to be a very simple API. I think it's actually going to be easier to use in terms of the API than Bitcoin RPC, because payments are, functionally instant. You create an invoice. The payment flow looks actually more similar to PayPal in terms of the API structure. Yes, there's a question?
Yeah. So when we read this a while ago, my sense was sort of like the net result on the network from the second bullet point. Basically, the result of the second bullet point is that you have naturally market forces make it so that there are super nodes in the network. In other words, one way to rephrase all of this would be you're opening a chain of payment channels, as you described, and fundamentally a payment channel necessitates that you have an upfront capital commitment to make that work and not have to reopen it a bunch of times, which defeats the whole purpose. So, do you think the end state of this is that there are a large or a small number of super nodes, or super nodes form and it's less distributed in the Lightning Network sense?
I think there will be more connected nodes than others, right? I think it's important to make the nodes non-identifiable and easily interchangeable. When it comes to highly connected nodes, it's not infinitely cheap. It's not going to be super nodes similar to BitTorrent or Skype peers, the way Skype worked 5-10 years ago. In terms of the super nodes, simply because there are costs involved. You do need to, locking up money is a bit of a misnomer. You're not really locking up money if there's payment flows, right? But if, let's say, your channel counterparty just doesn't touch their money at all, and you leave the money just sitting there, that's sort of just dead money, right? And that does have some time value component as a result. Now, if you have infinite monies and want to, connect to everyone with, unlimited amount of money, then yeah, that can happen. But there's no real advantage for you as a node to do that. And that's why I'm not actually that concerned about a node topology that's centralizing, because there's no network effect that benefits you, because they're relatively interchangeable. So if you start extracting a fair amount of rent on it, they'll just go with someone else. There are going to be more highly connected nodes for things involving smaller payments. So you may see, nodes which have some type of fund limit, have lower hop distances, but for more average payment sizes, let's say $1 or $5 or whatever it is, that type of model, it could end up being a little bit costly in order to try to be a super node. Obviously you can. I see it as potentially helping the network, simply because they're not really going to get anything out of it. That's my thinking. I think a lot of this is thinking of it. Hi.
Yeah, another question. Are you guys ready for questions?
Yeah. Oh. Yeah. I think we have a couple more slides, so we can
All right.
Yeah.
Okay. So, all right. I'm still trying to wrap my head around something, which is, so let's say we have a customer of Coinbase and they open a payment channel with Coinbase.
A direct payment channel?
Yeah. So it seems like they're kind of encumbering those funds, or the funds are sort of tied up as long as the payment channel is open. And then,
it's not necessarily tied up in the sense that they can spend it, right?
Probably more useful. It is tied up in that it's in this channel, but the thing is, it's having funds in channels that are on this network might be more useful than having a non-channel Bitcoin, because you can push it anywhere instantly. So it's yeah. Well,
even if they don't,
and everyone's using it, it's I'd rather have my stuff in channels, because then I can just suspend instantly instead of waiting for 10 minutes.
Yeah, even if they don't support Lightning, if you had some measure of small trust, you could have an exit node or something. Deal only in Lightning, have them making an on-chain transaction on your behalf.
Yeah, no, I totally agree. I think the potential of it is it could be very useful in the channel. I guess my question is let's imagine, I don't know, you want to use Uber or something. And I kind of have to think about what's a reasonable upper bound on what I might want to spend or something, and kind of pledge that. But then I might not use 100% of it or 90% of it. I might actually be using 10% of it or something. So it does feel like I'm having to tie up more assets in the channel than I might want to use as a safety measure.
Right. Well, but hopefully, let's say I'm going to use Uber, or customer opens a channel with Coinbase. And then Coinbase has a channel open with Uber, and so then when they want to pay Uber, they just say, hey, Coinbase, please forward this to Uber. And then you do. So like one channel is enough to pay everyone, really.
Okay, I guess
It's sort of like it's your money already, right? It's not really locked up in that sense where it's like it's usable.
Yeah.
The only situation where there is this structure where it feels locked up is if your channel counterparty is not really online all that much or doesn't want to route, which is why, you know, there is that cost if you want to be a quote unquote hub, because you're likely to get more of those types of users, and why it is costly to be that. And that's why there is that disincentive to operate in that way.
So, this is helping understand. So I think maybe let me take the analogy one step further, or the example one step further. So let's say a customer has a payment channel open with Coinbase, and they don't mind tying up those funds because they get to spend it through Coinbase or whatever.
The customer's happy.
Yeah, and then let's say we have a payment channel open with Uber, so that they can get instant payments. Does Coinbase need to have twice the capital on hand? Because we've encumbered one Bitcoin with the customer and one Bitcoin with Uber.
So you don't actually have to encumber the Bitcoin with the customer, because the customer could just unilaterally say, hey, I'm going to open a channel with Coinbase. I don't have any money on Coinbase, but I'm going to put 5 Bitcoins in this Coinbase channel. And Coinbase puts nothing up. But Coinbase does have to put up with Uber, because the payment flow is probably going to be customer to Coinbase, Coinbase to Uber. So you don't have to
I see. So it's the customers is a one-sided payment channel.
You could do
depending on which way the payment flows.
I actually think that initially it's a lot simpler to just have all the funding be one-sided, because then there's no trust whatsoever. Because if some random anonymous user says, hey, tie up 5 coins, and I'm going to tie up 5 coins, it's like, well, who are you? But if they're just saying, hey, I'm going to put my 5 coins in this channel, it costs you nothing. Coinbase can just say, yeah, sure. I don't know who this is. I mean, well, Coinbase maybe for regulatory reasons doesn't want to do that. I don't know. But, when it's on the network and a random anonymous person wants to open a channel with you and you're not putting up anything, yeah, why not?
And you only, let's say, hypothetically have this rule where you only do outbound, like you fund channels where, they're actually receiving payments.
Yeah. So if it's Uber, you're just like, yeah, let's put 20, 30, whatever coins in a channel with Uber, because we have a lot of customers that pay them.
That's helpful. Okay.
How about I just do the slides and then we'll do the Q&A. I could go back to this slide later. So the APIs will be actually simpler than Bitcoin RPC because you don't need to do as much tracking. Payments are atomic, where it's done or not done. There's no confirmations that you need to watch or something like that. Over time, where it's just it looks like a PayPal flow where you build an invoice, you submit it onto the API, and then you can it'll either call back or you can watch for it, which is substantially easier as a result. Now, if they're doing on-chain, there may be some complexities around that, but for off-chain purposes, it's substantially easier. The interesting thing is that the other implication is you may see crazy high volume. Visa can do 40,000 thereabouts, around the holidays. That's around what they do. This thing can easily do millions of transactions per second in a relatively, inter-network system. One node on a home computer can potentially do, many thousands. If you have a large routed network, yeah, we're talking millions of transactions per second. It makes it feasible to do extremely small micropayments. 100 satoshis or something can become economically feasible. And that may have implications when it comes to infrastructure. Obviously, people need to be using it, but as a result, these payment flows can happen. There's a lot of interesting applications. Do you want to go into this, or I can go into it? Yeah. So I think this is the last slide. Micropayments are really interesting. Pay publishers, pay-per-view, machine-to-machine payments, pay per API, that type of thing. Pay for bandwidth is really interesting. It sort of doesn't matter when you make the payments really small. It sort of doesn't matter whether it works or not, whether the access point is up or not. So you're just sort of well, I'll send you a Satoshi or 10 Satoshis. If they're a jerk, you're just well, connect somewhere else. Who cares? You can do multi-sig on this, which is fun. You could have escrow type structures off-chain, which is really fun. Instant payments, where the confirmation is provable. It is enforceable on-chain. You're deferring the enforceability, but ultimately it is enforceable. much like how, the court example. You can do cross-chain transfers. Alice and Bob is on Bitcoin, Bob and Carol's on Litecoin, or some kind of like bank chain or something. Do like instant cross transfers, and that can be really fun in the future. So what Lightning Network needs the malleability fix. This is what it wants really more than needs.
It works today without it, but it's a lot easier.
Yeah, it's way easier, and there's some benefits, but some kind of relative time lock. Without that, the channels have an expiration date. With that opcode, you can just leave these running for many years at a time, no problem. And some kind of accounting for person block sizes. I'll have some interesting things to say about that in the coming months, I think. And then coding it. So we have like a GitHub repo and stuff like that. Okay. Yeah. Okay.
Questions?
Yeah.
Okay, so let me paint what I think is a possible endgame of this, and then you can critique it, maybe.
Yeah.
So, so there, like you said, if the world is very well connected by the Lightning Network, then like it's valuable to have your Bitcoin in the Lightning Network, because hypothetically it can kind of go anywhere, et cetera. And you can avoid the higher fees of being on the normal Bitcoin blockchain and do more microtransactions, all that great stuff. It seems to me, though, like just going back to like the supernode idea, so naturally the incentive would be for, it's kind of like what Coinbase does now in a sense with our hot and cold storage, actually. Like if you're an individual user of Coinbase, you can readily have your funds accessible, but the reality is that behind the scenes, Coinbase stores 98% of funds offline, whereas you as an individual, if you were to store 98% of your funds offline, it's like extremely hard to use. We have the luxury of being able to accumulate and average all of our customers' activities such that we can store 98% offline, but one individual customer couldn't do that, right? So I think like the same principle applies here, basically, right? Where it's like let's say like one person used an average of 10 services in Bitcoin, you couldn't go and commit your capital to payment channels to all of those 10 services, but Coinbase, much in the same way, could go and average out customer activity and do that. So like it provides an incentive to have a centralized hub that can average activity where one user can't do it as much.
I think there's a little bit of a difference in that sense where, this is a routed network. So it sort of doesn't matter who you're connected to, and you can pay anyone first. Secondly, the value of, let's say you're an intermediary, like if you already have multiple channels open, you're not opening another one to, another hub. I think it's really cool that like Coinbase is thinking about this way and like optimizing for decentralization. And like being like concerned about that. The concern that a single node has significant advantages, though, like I don't see necessarily what the economic advantages are compared to the relative disadvantage of, there may be more intermittently connected nodes, and you may require a lot of funds in order to operate in this way.
Okay, so, and if this goes into too much more detail, maybe we can talk after, but my sense is that on the Lightning Network, ideally you have as few hops as possible, because it still requires some amount of effort to exchange signatures and update your channels and all that good stuff.
Not necessarily.
It's gonna be pretty uniform, even when, what's the difference between 3 hops and 5?
On the internet, it makes no difference.
And even if you have like tons of users, you're never gonna have more than like 6 or 7 hops, just because it's the way these graphs get built. It's always like log n hops, where n is the total number of nodes. So it's, there are some advantages when you have a direct channel. So when, like, there's sort of a qualitative difference between 1 hop, direct, and 2 hops. There's some things you might want direct channels for, but whether it's 2 or 3, it's like, it's probably going to be equally fast.
I would say one analogy that we've been using is like payments as packets. I mean, packets can route through, a variety of servers. Similarly, on Lightning, they can go through multi-hop.
Although we have to see. The thing is, like, we're building the software, but we're not building the network, right? It's sort of like, whoever wrote Bitcoin, they don't get to decide what people use on it. And so there may be network topologies like we haven't even anticipated. It feels like it'll work pretty well, and it feels like it'll be pretty decentralized, and we're, working to make it that way. And, we want to put like the defaults in the software to like help make that the case.
Yeah.
To some extent, it's like if a bunch of big companies try to dominate it and like get everyone to sign up with them as hubs, like
But what do they get out of it?
Okay, let me present one reason why this might happen.
That it's not that it's not possible because you can attempt to do it. What do you get out of it?
So here's what you would get out of it. So like you said, basically like the reason you have to commit capital up front is you want to open a payment channel such that you can do a bunch of microtransactions in the background that don't incur the cost of doing an on-chain transaction. But you have to put some amount of capital up front in order to open that payment channel. And if, let's say I open a payment channel for 2 Bitcoin, if 2 Bitcoin gets sent from A to B, then without any capital going back the other way, you have to open a new one and restart the whole thing, right? Like the limit of the, okay, wait, what's wrong with that?
It works fairly well. So there's sort of fee schedules that we have programmed so that you can charge a fee to forward a payment, right? You can say like, okay, you're sending a Bitcoin through MyHop, but I'm going to charge like a 20 Satoshi fee or whatever, something small,
one or
whatever it is. But by default, as the channel becomes more sort of asymmetric and like lopsided, like all the coins are on one side of the channel, you charge more and more to push funds that way. So you basically want like your fee structure is such that it self-balances. So,
but that's only for more like interconnected nodes that like where like if you're a Leaf node, it doesn't matter.
Yeah, if you only have like one channel to some other company, then yeah, it doesn't really matter what you're doing.
But like, like it's like if you're basically not routing on behalf of others, you don't want that policy. But if you are, then you do want that policy.
Yeah, so there probably will be sort of tiers in that, like, you want to call them leaves. There's some nodes.
It's not really leaves. It's more.
The software's all the same, but if you only have one channel, well, you're sort of by definition a leaf, right?
Maybe we can talk about this more at lunch because I don't want to take everybody else's time.
Yeah, that's good.
It's actually kind of in the same direction, so sorry, Fred. But you talked about the fee structure for forwarding payments, and there's also this kind of notion that you have to put up a bunch of capital if you're going to be paying out to a lot of different participants in the network. So it would make sense to me that there would kind of arise this economic incentive to be a supernode if we, like, for example, as Coinbase, can charge a fee to forward payments to this plethora of other merchants that, a lot of other people don't have the capital to do. It seems like that's totally economically viable for us to charge fees to do that.
But the entry costs are zero effectively.
Yeah, so you can charge fees, but if the fee so like one pretty hard limit is if the fee is larger than an on-chain transaction fee, people are just going to open a different channel.
But that's not even. That's like
right. So that's like the super high. The other thing is there's a lot of we've talked to people. There's a lot of people with Bitcoin, and they're like, oh, I'm going to run a Lightning node. And I'm going to get
so
much money.
Rich. We're going to be so rich.
And they're like, I have a decent amount of Bitcoin. I'm going to run my computer. Everyone's going to connect through me. I'm going to charge fees. And like, the thing is, there's a lot of people saying that, so there's going to be a lot of competition. It sort of feels like mining, but worse.
Yeah, it's way worse than mining.
Not even capital costs to get the equipment. All you need is like a computer and an internet connection in Bitcoin. So I think competition is going to be quite fierce, and there's not a lot of barriers to entry. So yeah, Coinbase can do it. I wouldn't sort of bet that you're going to make a ton of money off of it. But if existing Coinbase customers, you can sort of offer that like, use it right away.
But the fees that people charge are going to be effectively near zero. If you really game it out for a lot of payments, 1 Satoshi is too high. That's really what we're looking at.
But yeah, it's Lightning. You might not make too much money off running nodes. It'll make Bitcoin. It feels like what we're pushing is use this as like accepting payments, routing stuff. It'll work great. But making money off the intermediate routing, it's really hard. Just because it's so easy to like spin up new nodes and like
switching costs are effectively zero. It's not like the internet, right? The internet, there's actual physical connectivity, and you can extract rent from that. With this, it's a virtual layer on top of that. It's like saying, like you can. This basically it's the function. It's a function of the cost of the transaction fees on chain, which is pretty cheap. And even if it like goes obscene, which ideally it shouldn't go obscene, but even if it's like something crazy like $20, you're not going to be able to extract much rent simply because of the switching costs.
Just for clarity, we're not trying to make any money off this. So
yeah. But I think it's really cool that Coinbase is thinking about that because it's sort of like you guys want to, the questions that I'm getting is sort of like, hey, how can we make this decentralized? This concerns us, and I think that's really cool.
Sure.
So Joseph, so for Lightning Network, you're trying to find a path between Alice and Bob, right?
Or Carol or Dave or
and then it goes through different nodes, and each path, each node takes a different fee, right?
Mm-hmm.
So it's kind of like trying to find the shortest path because the cost will be different paths you take. How do you do that in a kind of decentralized manner, if possible?
So, okay, that's sort of like a two-part answer. The first part is how do you sort of discover routes? There's multiple strategies to do so. So one example is, you have a list of, multi-hop paths that you tell Bob, and Bob compares it to their list of multi-hop paths. They see a match, they're able to route payments. Now, that becomes a little bit more complex when there's variable fees. My answer to that is I actually think the fee structures will be very flat. What ends up happening is that if the channels become lopsided for the intermediate nodes, what you want to do as those intermediate nodes is be able to encourage the channels to be relatively balanced and not be lopsided. So what you do is, even before you receive the payments, you reflow the network to be more balanced based on your other channels. So you fund your flows in a circle across different channels, and you ensure that there is some type of baseline fee. I think there's probably going to be various shelling points for the fees, and I think it's going to be relatively, it's going to match, I think. But that's not a guarantee, but it's what I think.
You can loop. So if you in this, like, you can say, this is asymmetric, so I want to like loop that way and move funds back to myself to balance out.
And fees can be signed, so it's signed so that like it can be negative. You can have negative fees to incentivize money flowing in other ways.
So, sort of piggybacking on Charlie's question, but have you guys thought about what the user interface would need to be for this, and does it change at all from a traditional Bitcoin wallet? Like, I'm imagining somebody comes in, they have one Bitcoin in their Coinbase account. We could actually just set it up in a payment channel without them really having to know about that or care. But then they say, hey, I want to send 0.1 Bitcoin to this Bitcoin address. And then what happens? Like, behind the scenes, we have to do this kind of like depth first search to various things to see if one of them is on a network of payment channels, and if not, then put it on chain or something like that?
So, on the back end, on the second half of that question, the API will handle all of that. So it's sort of like, I don't care how it gets routed, just do it for me, And you just say, like, I'm sending it to this person, and it'll be like, okay, great, we'll figure it out.
Which API is this? This is what you guys are building?
So it'll just be like, I'm sending it to them, and the software just handles it all, and it's just, much like how you don't care about how it's routed to the miner right now for on-chain payments, it's just sort of like, just do it for me.
Mm-hmm.
When it comes to the user interface, I think on the most highest level, right, I think the user interface can be potentially easier to use than Bitcoin today, simply because a lot of the uncertainty and a lot of the stuff you see when it comes to like confirmations and various things, a lot of that will be removed, and as a result, I think the user interface will be easier. Some aspects are undiscovered, so I think there's some areas to explore. The part on the technical side of the user interface is the identification of people. So what we're looking at is Bitcoin addresses will look the same in Lightning. So you can use existing Bitcoin addresses, so that way it's backwards compatible. You can receive funds on chain or in Lightning. If they don't support Lightning, then you just receive funds on chain. The second part of that is some kind of address endpoint, because Alice directly needs to communicate with Bob. So what happens is, the Bitcoin URIs and the QR codes are backwards compatible and look the same, except there's an additional field.
Yeah. Right now in the code, it's just like pubkey hash at IP address. So you just directly connect over IP. But we can add like DHTs or something later.
And by the way, there can be like some advanced settings, but the way we're envisioning a UI is like the user does not know any of this that's going.
Although right now it's all right now it's all command line, so like there isn't really a fancy UI, but you see everything that's going on.
But no, Coinbase is like really knowledgeable about this kind of stuff. So I mean, like, I don't want to,
Yeah. And then you can have like an expert mode like thing where you're like, I want to see my channels and stuff.
Oh, I like expert mode.
Most people.
Actually, sorry, follow up to that real quick, and then Jory, I'll toss you the catch box. So how quickly will it be able to, traverse that network to kind of return back to you? Yes, there is a payment channel path somewhere, or no? Are you thinking like
less than a second or two?
Okay, and I mean, I'd be curious to know how you guys are building that and everything. That's part of a later discussion. But I guess imagine a world where, Lightning Network is kind of rolling out, but not everybody supports it yet. So it's like 50% of stuff works on Lightning, 50% doesn't. Now somebody comes to Coinbase and they open a wallet and they put in 1 Bitcoin. And if they try to send to an address that's not on a Lightning network, we've got to put it on chain. And so we can't use, I presume, the funds that they've encumbered in the payment channel to us. Could you?
Say, push the funds to Coinbase on the channel, and then Coinbase, once they've received that on the channel, will make a on-chain transaction on their behalf.
So you can cooperatively close that pretty much immediately, and they just go on chain.
So what happens is, you make the payment inside Lightning, you send it to Coinbase, so the funds, and then Coinbase actually makes the on-chain on their behalf. What happens is at that point the user is trusting Coinbase to some marginal level.
Got it. Yeah. That's pretty awesome.
There's a key element to this, which is that we control the Bitcoin for them as is. So this is basically like correspondent banking 2.0 in my mind. It's like we have a bunch of people's money, so we can route it to a bunch of other places on their behalf. So there is no payment channel between a Coinbase customer and Coinbase. We already have their Bitcoin, such that we just have a bunch of these channels open for what we see as the most common uses in Bitcoin, and then those.
You could also have multiple nodes with sort of virtual channels, in that there's no actual channel, but you're well, if the node here receives money, we're the same entity, so we can credit a node on the other side.
I would say having this on-chain, off-chain link is something that Coinbase can absolutely do, because I think a lot of people, because you are in a way trusting someone to exit the Lightning Network to go on chain to make a payment to bridge this adoption curve. I think that is something which Coinbase is well suited to do.
Okay, going a little bit on the practical side. So it sounds like you're basically at this point you're building software which acts like Bitcoin D and so on. So one implementation of the stuff, but you still have to figure out a whole lot of routing stuff and so on. What do you see? What's the path, the adoption? How far is that? Which steps does it take to happen? How far are you guys?
Yeah. Okay. So when it comes to progress, I think we have code up on GitHub. It's in progress, but we'll have it working on the SegWit testnet in about I want to say 2 months. That's the target, but things could actually be earlier, could be later, but I think could be earlier.
The SegWit gets into the mainnet, hopefully later this year, summer or so. We don't know. We should be able to have everything running on mainnet by then.
And that's having a command line interface ready with mainnet. When it comes to the actual adoption process, I don't think there's necessarily that much of a problem, simply because there is backwards compatibility. Now, obviously, you can't make 1 Satoshi payments on chain reliably, but when it comes to the way people use Bitcoin today, it'll be very much a opt-in structure where you're able to be able to do payments in Lightning if they support it, and if they don't, then go on chain. And that kind of structure allows for a smooth adoption curve.
So it seems like as part of this revoking previous transaction structure, the assumption is that all the nodes are online at all times to monitor and make sure that they're not getting ripped off.
So they have to be online to route and to pay each other and receive payment. So the one thing is, in Bitcoin you can be offline and receive. On Lightning you do need to be online to receive.
Well, there's things you can do to get around that.
But the monitoring you can outsource. So that Bob 0.5 must know secret thing. Once Bob knows the secret, he can take that entire transaction, which spends from the time locked 0.5, and hand it to Coinbase, hand it to anyone, because that's just a transaction. There's no private key involved. And just say, hey, if you ever see this time locked 0.5 out, pub key script on any transaction that's on the chain, please broadcast this other one. And you can outsource that.
Yeah, and you can make an additional output of 0.00001, where you're just for the person responsible for broadcasting this.
Yeah, so there's you can even incentivize, say hey, you'll get a little bit if you broadcast this for me. In practice, I think people will do it for free, because
people probably do it for free.
All you have to do is monitor the blockchain and broadcast the transaction when you see something. So
and store all the transactions.
Yeah. So there's some storage, but
Or just cheap now.
Pretty easy to do. So, and it's also like, how many do you really need? Like, if it costs a lot of money, I'll just be like, yo, can you run this on your computer? And can you run this on, like give it to your friends, whatever. It's outsourceable and like trustlessly outsourceable. You're just trusting that they don't fall asleep at the wheel and like stop monitoring.
But you can have 100 people, doing that on your behalf.
Yeah. So that part is fairly
you
safe.
do it yourself.
And then obviously your actual Lightning, your wallet or your software also monitors. Every time you
that's all a backup, like what we've been talking about. You can make this time lock, 14 days, whatever you want.
Right. The trade-off there is the longer the time lock, when you want to close because the counterparty has gone offline, then you have to wait that long to get your money back. So 3 days, I don't know, default, couple days. Yeah.
So you can actually close the network like immediately, have both parties get money
if it's
back,
cooperative. Right? So if Alice and Bob are totally cool and they're like, hey, it's not me, it's you, it's been working out, whatever. Or no, wait, it's not you, it's me. Anyway, if they are cooperative in their close, they don't use any of these, and they just make a totally new, immediate transaction.
So there's like it's not on here, but there's just another one that says Bob gets 0.7, Alice gets 0.3, no time locks.
No time locks, anything. We just sign it and immediately broadcast.
And to be clear, this is what we envision to be the vast majority of use cases on the network, and we were talking about like edge cases.
So the edge cases are like what you have to design for, but in practice, everyone always does.
The fun thing about all of this is that you're designing like, there's like 8 different transactions.
Never happen.
None of this stuff happens. It's like the fact that this can happen means it doesn't happen.
Yeah. Oh, okay. There's gonna be sometimes people go offline. So that probably the only legitimate is like, okay, the node goes offline and you like waited a couple hours, like, I'm going to close the channel myself. So that can happen sometimes, but usually it'll all work.
Kind of like GitHub going down, right?
Okay.
So basically I'm wondering, because all the nodes are anonymous, I'm wondering if you see an opportunity for like a Sybil attack where you basically pay mining fees and just continuously drop connections and go offline. This would be like purely malicious. You wouldn't gain anything.
You have to pay transaction fees, though.
Yeah, and you have to pay transaction fees every time you do it. I'm just wondering if you see that. It's like a DDoS sort of. It's like DDoS is to fill blocks.
It's expensive, though.
I think the other thing that mitigates that, you can try to do some of these things. The thing that mitigates it is initially you open channels not to random people, but to people you're trying to pay.
Yep.
So if I have my wallet and I'm like, okay, I'm going to use Uber, I'll open a channel to Uber. And so there's it's not trust, but it's like, I know who I'm paying, so they're probably not going to try to troll me.
They kind of want your money.
Yeah, they want. So initially, at least, you're not going to be putting up funds. And similarly, like when someone wants to open a channel with you, you're like, well, I'm not going to put anything in here unless I know you. If you're anonymous, I'll let you open a channel with me, but there's no cost to me. So that initially will help it build out without those problems. But yeah.
But if it, hypothetically even, that should be sufficient. But let's say hypothetically it isn't, which I think is improbable to basically impossible. You could hypothetically require, them to also put up a little bit as well, so that it slows down that attack vector. Okay, cool.
Thanks.
Yeah, it was really great speaking here. You guys are awesome.